Hi everyone, it's Lauren with the Atlanta Botanical Garden. Today I'm with our classroom amphibian collection to share a fun amphibian fact with you. Did you know that amphibians like frogs and salamanders don't drink water in the same way that humans and many other animals do? To help explain, I've invited a friend and our resident amphibian keeper, Chelsea Thomas.
Hi, I'm Chelsea, and I'm an amphibian keeper here at the Atlanta Botanical Garden. I raise many different species of amphibians, animals like frogs, toads, salamanders, and newts that are defined by their ability to absorb oxygen and water straight into their skin. Amphibians have extra special skin because theirs is a mucous membrane. That's right, mucus, like the stuff that comes out of your nose. This is a slimy salamander, and she's a great example of an amphibian. This slimy salamander lives up to her name, with shiny, slimy, mucosal skin. Amphibians drink directly through their skin. All their skin can absorb some water, but patches on their legs and undersides can do it really well. So while most animals have to wait for water to cool up and then drink with their mouths, an amphibian can just sit in the rain and pull the water directly into her body. This can be really helpful. Like if it hasn't rained in a while and the ponds are all dried up, a frog can sit in the mud and draw water out of that. Or if a tree frog lives his whole life up in the trees, he can soak water out of damp moss without ever going to the ground where predators might be waiting.
Thanks, Chelsea. Although you and I won't be drinking from our skin like frogs anytime soon, we can still create a model using a chicken egg to examine this cool phenomena. Come on, I'll show you.
Let's make a frog skin model. You will need 2 clear containers, plastic wrap, a rubber band, a scale, measuring tape, chicken egg. We're using 3 eggs in case 1 or 2 of them breaks. White vinegar, water, time. Be aware that this experiment takes several days to complete. Start by taking measurements of the chicken egg. Use the scale to measure the mass of the egg in grams and the measuring tape to determine the circumference in centimeters. Carefully place the egg in one container and cover with vinegar. Cover the opening of the container with plastic wrap and affix with a rubber band. Now it's time to wait. It may take anywhere between 24 to 48 hours before your eggs are ready to use. What's happening here? Chicken eggshells are made up of calcium carbonate. The hard calcium carbonate breaks down as it reacts with the vinegar. Water and tiny bubbles of carbon dioxide are released, leaving behind the squishy, slimy inner membrane of the egg. When most of the eggshell has dissolved, remove the egg from the vinegar and rinse. Be careful! Without its hard shell, the egg can easily burst. Whoopsies! Take measurements of your slimy egg again. This slimy, shellless egg is your frog skin model. Let's test it out. Place the slimy egg in the second container and cover with water. Cover the opening of the container with plastic wrap and affix with a rubber band. Let the container sit overnight. Carefully remove the egg from the water. Make observations and measure the egg again. Did your frog skin model drink water? How can you tell? The eggs that we measured increased in both mass and circumference after removing their shells and placing them in water. So, how does this happen? The process that allows the egg to absorb water and also is partly responsible for a frog's water absorption is called osmosis. Osmosis is a movement of water from high concentration to low concentration until the water concentration evens out or reaches equilibrium. Our frog model has less water on the inside of its slimy skin than on the outside. Water from the container moves through the pores of the frog model until the water molecules are spread out evenly. This causes the egg to drink and expand.
Now that we've tested our frog skin model and have a generalized understanding of how frogs can absorb water through their skin, we can use this model to create new simulations to see how frogs might be affected in different habitats or environments. You can use your model to see how frogs might be affected by salty ocean water or even polluted water, and then use those findings to help design solutions to protect these wonderful animals out in the wild. Thanks for joining me today. Happy sciencing! You made this look really easy.